All right, everybody, welcome. So today will be our first lesson where we solve equations where we have this radical symbol, okay? And we'll explain all the little tiny details about it and how to solve these types of equations. What I'd like you to do for question 1 and the next one, question 2 over here, first take a second to copy it down. And then what I'd like you to do for each question is 1, or first part A, describe each step taken to solve this equation. So notice that this is the first part of the equation, the second part, then the third part. And the same thing goes for this one over here. So what I'd like you to do is on this side here, just describe what you think is happening to get from here to here to here. And then at the end, check the solution to see if it's valid. So whatever answer we get for x, which we already have here, which is shown for you, let's plug it into the original to see what's happening, okay? And what happens when we plug in 100 into the square root x, right? So here, for the first part, let's take a look. Here, it's saying, okay, so how do you go from here to here? What do you notice is happening? How did we get rid of this minus 6 over here? What did we do? We added 6, we added 6. So add 6 to both sides. Okay, so now we have square root of x. So this is from here to here, right? Now from here to here, we just added 6 on both sides. Now, how did we go from here to here? This gets a little bit tricky because we haven't really seen we haven't done this operation together. But the idea is, if I go from square root of x to just x, and how do I get from 10 to 100? Notice, how do you get from 10 to 100? You could multiply by 10, but you're not multiplying 10 on this side. What you're doing is you're squaring this. 10 squared is going to be 10 times 10, which is 100. Here, what you're doing is you're squaring this square root of x. And if you have the square root symbol, and you square it on the outside, these two cancel each other. And why they cancel each other, I will explain not in this video, but later on when we go deeper into this topic, I'll explain why they cancel. But for now, let's just assume that this squaring, this square root, cancels it. So we're just left with x equals 100. Yeah? Now, let's just check. If I have the original equation, which is square root of x minus 6 equals 4. Well, let's see. If I plug in x equals 100, well, we get square root of 100 minus 6. Does that equal 4? Now, what does it mean to take the square root of 100? Just for a quick little reminder, if I said, hey, what is this symbol asking from us? Example, if I said square root of 36, what is this saying in your own words, in your head? What number times itself twice will give me 36, right? And that value would be 6. What number times itself gives me 36? Well, what number times itself gives me 100? It's 10, right? Because 10 times 10 is 100. So 10 minus 6 equals 4. 4 equals 4, and it checks. Happy face. All right. What I'd like you to do is try and follow the next one by yourself. Yeah? Same kind of idea. Here, what was the first move we did? We, again, add 6 on both sides. Okay? Because we do plus 6 plus 6. And then now notice, how did we get from here to here? What are we doing? We are cubing both sides. Okay? Here, this expression square, we write it like a geometric square like this. We're squaring both sides. Cube, so here we are cubing both sides. We're matching what's happening to get rid of this cubic root over here. We're going to cube both sides. So notice that these cancel. We're just left with x, and 10 to the 3 will be 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. So then we're just left with 1,000 here. And then let's just make sure that, just for a quick little review, what is this symbol asking from us? This is the cubic root. So this is the cubic root. Example, if I said cube root of 64, what is that asking us? It's saying, hey, what number times itself 3 times gives us 64? Pause the video and think about it. Give me one number, when you multiply it by itself 3 times, gives me 64. Let's see, if I did 1, like 1 cubed is 1 times 1 times 1, and that's 1. 2 cubed is 2 times 2 times 2, and that is 8. 3 cubed is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 4 cubed is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So this is equal to 4. Why don't you take a second and, take a second and try these on your own. Have some fun with it. Pause the video. Yeah. And let's say you want to see the answers. Okay. So here, just to check it, if we had cube root of 1,000 minus 6, does it equal 4? Like if I substitute this x back in here, the cube root of 1,000, what number times itself 3 times gives us 1,000? It's 10. So then we just get 10 minus 6 is 4. 4 equals 4. Check. And we're all good. Okay? So here, the question I ask is, what was the general strategy for solving questions 1 and 2? What was the motivation of the first move of adding 6 to both sides? How do we solve equations where we have these radical symbols or these cubic root symbols? What's the strategy we want? We want to get the square root by itself. Okay? Notice that here in this problem we got this square root by itself, and here we got the cube root by itself. I'll explain, or why don't you try and answer this question. Why do you want to get the square root or the cubic root by itself? Yeah? Okay. Here, let's try and have some fun and let's solve these equations. What I'd like you to do is, let's try this one together, right? Strategy is, get the square root symbol by itself. So notice that if we have the square root of 7x plus 123 plus 11 equals 20, let's get this symbol, let's get this term by itself. So what would we do? Let's subtract 11, subtract 11, okay? So we have square root of 7x plus 123 is equal to 9. Now, what was the purpose of getting the square root by itself? Because what's one new technique that we're allowed to do? We're not allowed to do. I'm sorry. What's one new technique that we just learned to do is we're allowed to square both sides. By squaring both sides, the square will get rid of this, so you're just left with this 7x plus 123 is equal to, now, what is 9 squared? If you say 18, my heart breaks. You're not doing, remember, 9 squared will be 9 times 9. So this will be 81. And once we get an equation that looks like this should be easy money, right? Once we get an equation like this, how do you get x by itself? Right? Pause the video and try and go for it, right? What do? We subtract 123, subtract 123. So then we just get 7x equals negative 42. So then if you get 7x, I'll write it over here. If we get 7x equals negative 42, how do we get the x by itself? Just divide 7, x equals negative 6. Okay? But this isn't enough. Let's check it. Let's just do a quick little check. Try and check it on your own. And I don't have space here, so what I'll do is I'll just kind of extend it with a piece of paper over here. What does the check look like? The original equation is what? Square root of 7x plus 123 plus 11 equals 20. So we know that x is equal to what? Negative 6. Okay? So square root of 7 times negative 6 plus 123 plus 11 equals 20. Now it's very important to understand that this 11 is on the outside of the square root, right? So don't start adding 11 to whatever this is here. So we have square root of negative 42 plus 123 plus 11 equals 20. Negative 42 plus 123 is, take your time, what is this? This is 81. 81 plus square root of 81 plus 11 equals 20. Now you cannot combine these two. Don't think it's just becomes square root of 92. We have to evaluate this. What is the square root of 81? What number times itself gives me 81? 9. 9 plus 11 is 20. 20 equals 20. Check. Alright, very nice, very nice. Try the next one on your own. You got this. Pause the video and try this one on your own. Okay. What's our first move? We want to get the radical by itself. So let's add 19, add 19. So now we're left with square root of 2x plus 17 is equal to 3. Right? Negative 16 plus 19 is 3, and negative 19 plus 19, this is 0. Right? Okay. Why did we add 19 on both sides? So we can get the square root by itself. Now that the square root is by itself, what can we do? We can square both sides. So then this cancels, and what are we left with? 2x plus 17 is equal to 9. And then once we get to here, this should be not too bad to solve, right? You got this. How would you continue forward? Pause the video. Like if you didn't get to this point and you got to this point here, how would you solve it? Like minus 17 minus 17. So then we get 2x is equal to 9 minus 17 is negative 8. So then if I get 2x equals negative 8, divide 2, x equals negative 4. That's it. But it's not enough. Check it real quick. Plug in negative 4 into the original. Do we get one side equal to another side? Well, let's see. If I were to check it, if I had square root of 2x plus 17 minus 19, I'm sorry, the square root of 2x plus 17 minus 19 equals negative 16, when x equals negative 4. Okay, so we plug in negative 4 in here, so we get square root of 2 times negative 4 plus 17 minus 19 equals negative 16. So then square root of negative 8 plus 17 minus 19 equals negative 16. Square root of 9 minus 19 equals negative 16. Square root of 9, oh sorry, my camera angle is very bad. Square root of 9 is 3 minus 16 equals, I'm sorry, 3 minus 19 equals negative 16. 3 minus 19 is negative 16. Negative 16 equals negative 16. Check. Okay. Here, I hope this lesson was fine. on Delta Math, there are some questions for you to practice. And notice that today we only worked on level 1 questions. There are more difficult types of radical equations that get a little bit more tricky. Like what happens if you have 2 radicals in the equation? How would you solve something like that? Okay. Enjoy. I'll see you soon.